This drill battery survived years of work without a problem. Then one accidental drop was enough to make the drill completely unresponsive. Most people would blame the impact and throw the battery away. But sometimes the real problem is much simpler than it appears. Today I'm going to investigate what happened inside and see if this battery can be repaired. Welcome back to Dan Fix. I'm Dan. The first thing I want to do is confirm the problem. Next, I place the battery onto the charger. Normally, the charging indicator changes color as soon as the charger recognizes the battery. This time, nothing happens. The charger refuses to communicate with it. At this point, we know there is definitely a problem, but we still don't know whether the battery cells are damaged or if the issue is somewhere else inside the pack. The only way to know is to open it. I remove the screws one by one. The cover lifts off. Then I carefully pull the battery assembly out of the plastic housing and place the empty shell aside. Immediately, something stands out. There is far more dust inside than I expected. A battery used in workshops, garages, or construction environments constantly pulls in fine dust through small openings. Over time, that contamination can collect around the circuit board and electrical contacts. Now it's time for a quick electrical check. I connect a small LED directly to the battery output. The LED remains completely dark, no light at all. To confirm the result, I switch to a multimeter. The probes touch the output terminals, still nothing, no measurable voltage. This is where diagnostic thinking becomes important. A battery that shows no voltage isn't always permanently dead. Sometimes the protection circuit shuts down after a deep discharge, a poor connection, or even a sudden impact. That possibility is exactly why I don't want to throw this battery away yet. The next step is cleaning the electronics more thoroughly. Instead of spraying directly onto the board, I apply a small amount of WD-40 into a cup. Then I dip a cotton swab into the liquid. Working slowly, I begin cleaning every exposed section of the circuit board. The swab moves around the solder joints, across the charging contacts, into the corners where dust likes to collect. After only a few passes, the cotton swab starts turning dark. That tells us it is removing contamination from the surface. Once the swab becomes dirty, I replace it with a fresh one. Then I continue. A clean surface helps reduce unwanted resistance and improves electrical contact between components. WD-40 is especially useful here because it helps remove moisture, loosen dirt, and clean light oxidation from metal surfaces. Little by little, the board starts looking almost new again. I continue around every connection point until no more dirt appears on the cotton swabs. With the circuit board cleaned, attention shifts to the charging contacts. These metal surfaces are responsible for transferring power between the charger and the battery. If oxidation forms here, communication can fail. Using fine sandpaper, I gently polish each contact. The dull surface slowly becomes brighter. A small amount of oxidation disappears. The purpose isn't to remove metal. It's simply to expose a cleaner conductive surface. After sanding, I use tweezers to inspect the contacts and nearby solder joints. A hard impact can sometimes loosen a connection. I gently press each area and look for movement. Everything appears solid. No broken solder joints, no obvious damage. That's encouraging. Before putting everything back together, I clean the plastic housing as well. Dust has accumulated throughout the inside. By the way, I'm curious. If you work in a workshop or construction environment, do you regularly clean your battery packs? Or do you usually wait until something stops working? Let me know in the comments. I'm always interested in learning what maintenance routines work best for you. Now it's time to reassemble the battery. The battery pack slides back into its original position. The contacts are aligned carefully. The cover goes back on. Then each screw is tightened until the housing feels solid again. Unfortunately, the battery still isn't responding. That means we're moving to the next stage, a controlled wake-up procedure. For this step, I prepare 2 short wires, 2 alligator clips, and 2 metal washers. The insulation is stripped from the wire ends. One end of each wire connects to an alligator clip. The opposite ends connect to the metal washers. These washers will act as temporary contact points inside the charging terminals of the battery. The goal is simple. We need a safe way to introduce external power into the battery pack. After tightening every connection, I give each wire a gentle pull test. Nothing comes loose. The tool is ready. The washers are inserted into the battery terminals. Each one sits firmly against a contact. Next, the alligator clips are connected to a 12-volt car battery. Positive to positive, negative to negative. Everything is checked twice before proceeding. Now we wait. This isn't intended to fully charge the battery. The purpose is simply to provide enough energy for the protection circuit to recognize that the cells are still present. Sometimes that's all it takes to wake a sleeping battery. About 1 minute later, it's time to test again. The LED is connected first. This time the light comes on immediately. That's a very good sign. Next comes the multimeter. The probes touch the terminals. Now we finally have measurable voltage. The battery is alive again, but there is still one more test that matters. Can it actually work under load? I place the battery onto the charger. Almost instantly, the charging indicator changes color. The charger finally recognizes the battery. That confirms communication has been restored. After allowing the battery to charge fully, it's time for the moment of truth. The battery slides back into the drill. I pull the trigger. The motor spins instantly, strong, smooth, just like before. Next comes a real-world test. A wood drill bit is installed. The drill cuts through the wood with no hesitation. Then I switch to a metal drilling test. Again, the drill performs surprisingly well. Plenty of torque, plenty of power, and no signs of weakness. What looked like a completely dead battery turned out to be something much simpler. This is exactly why diagnosis matters. Sometimes a battery doesn't need replacement. Sometimes it just needs attention. If you enjoyed this repair and learned something new today, leave a comment below and share your own battery repair experiences. Don't forget to like the video and subscribe to the channel for more DIY projects and practical repairs. Thanks for watching, and I'll see you in the next one.